Okay, looks like things are ready to go. Good afternoon. Hope things are well with all of you. Just serenading my wife verse of yesterday. All the snowflakes seem so far away. And they are banging up against my window today. Gotta love springs in Northeast Ohio. I've lived here since 1995. I still haven't got used to it. I grew up in Iowa, and springs in Iowa were springs. You know, it's got warmer and warmer. It didn't snow 15 days in April. Oh well, do what we can do, I guess. I have a bunch of information, and we have an activity to go over today. We put up the schedule of things that's coming up soon. So Wednesday we'll have a review session. We'll make that at 12 o'clock noon. And it'll probably, I know they seem to run an hour to an hour and a half. Thursday, we'll have another review session. About 1 o'clock p.m., I guess. I'm pretty sure, no, that's gonna be too late. 11 o'clock a.m., that's right. That's what we did last, for the last test, I'm fairly sure as well. So that'll give you a couple hours in there to get ready. Don't forget that exam number 4, of course, is Thursday. I have the exam, I'd say it's 70% written, and the 30% that isn't written, the questions are formulated in my head. So I'm feeling pretty good about it. It's a matter one more time of taking questions that I want to ask and getting them set up for this format. And this is certainly going a whole lot easier. Yeah, there is a quiz today. It's going to be one. Actually, it's going to be 2 questions. I'm going to ask you, basically, it's one problem. I give you 2 equations, ask you to find the expression that will give you the area between the curves, and then ask you to find the exact area between those 2 curves. So it'd be something like problem 1b on the last act, or maybe this was problem 2 or problem 3. There are two functions only. They only cross in 2 points, so it's not going to be one of those where you need 2 separate definite integrals. Just 2 equations. The solution where they're equal to each other should be straightforward. So finding the limits of integration should be easy enough. Subtract the upper function minus lower function, take the antiderivative, and off you go. So yes, that is today's quiz. 2 questions in length, but really just one problem. Again, 2 functions. Find the area between those 2 functions. That's the quiz. I think it's scheduled to open at 3:15 in this class. I thought today's activity was pretty short, and as we go through that, I'm anticipating as the questions go through, we should be able to get that done in an hour. I was able to figure out how I want the answers to look. Oh, by the way, the first half of today's quiz, you will be required to use the equation editor. I think I had 2 students who were still having difficulty with that. And if you're still one of those 2, if you can't get it done today, talk to me after class, set up a quick collaborate with me, because I want to be able to use that on the test, and setting up definite integrals is really, really hard without it. So make sure you can use that equation editor. I know there's a couple students that are struggling just a bit with that still. And I want to make sure that it's 100% ready to go when the test rolls around on Thursday, that everyone understands exactly how to use it. I guess getting access to it was the issue for a couple of students. All right, so what else do you want to know today besides a little info about the quiz? 1B it is. So in 1B, we want the percentage of the wealth at the bottom 80% control. And the Lorenz curve itself does that. So 80% would be 8/10 as a proportion. So we're going to calculate L of 0.8. Put that back into the function L. See, that was 0.3. Whoops. Yeah, a little slower on that. According to L of P function, L of P was 0.3P, so it's 0.3 times 0.8 plus 0.7P to the fifth. So that'd be 0.8 to the fifth power. So we'll do those calculations. This is 0.24 plus, yeah, my little cheap calculator here can do this one if I think about it a little bit. So we have 0.8 times 0.8 times 0.8 two more times. That's about 0.33 if I round. Adding those together, 0.57. Hopefully I got that one done right. Okay. So there, that the Lorenz curve itself, yeah, with B done, we'll figure out C. So this gives us the input is the percentage of the proportion of the population. This is the proportion of the wealth. So the bottom 80% control 57% of the wealth. So with that in mind, let's see if we can come up with what C should be. Now that we know what the bottom 80% control, the huddled mass is 4 out of 5. That big group is, if here's our whole population, this whole group of folks controls 57% of the wealth. So now let's see if we can get that other half. What would the other, the top 20%, how much wealth would they? You're always inputting the bottom certain portion, and it spits out the bottom proportion of either the wealth or the income. So how could we, if we know the bottom 80% control 57% of the wealth, did they ask the top 20%? Fairly sure you did. Yep. What did the top 20% control? Sure. Yeah, the rest of it. And let's make double sure. I wonder if I forgot. I might have forgotten to multiply that by 0.7. This might be too big. Someone with a little better calculator than mine. I'm having a strong suspicion that I forgot to multiply by 0.7 at the end, because that looks just way too big for my my thinking. Maybe it's not, but my suspicion is it is. Yeah. Okay. So let's I screwed that one up looking back at it. So when you add those two together, you get 43%. Yeah. Or 47%. Oh no, you got 47. Okay. Let's see. Okay. 1 minus point. Got 0.469. Okay. Yeah, so I did screw that up. going to run that through my calculator one more time. 0.8 times 0.8 times. Yeah, man. You need to invest in a better calculator. Fortunately, I have the answer key here. I should have thought of that a little earlier. Pretty well, I checked these over yesterday. Yep. So I did. I forgot to multiply that by 0.7 after I did the 0.8 to the fifth. So yeah, add those together. It's 0.47. So they control 47% of the wealth, while the rest of them control everything else, 53%. So the top 20% have more than half the wealth, and that's not an unusual thing, especially if you look at the problems that go a little later on this page, right? Looking down at, so problem number 3, income wealth. You got to look at the wealth Gini index. It's 0.86 in 2016, and this one only had a Gini index of 0.47. So yeah, it's quite a difference. Do 1A, sure. 1A, we'll just plug, let's see. 1A, we want to double the area between the equal distribution curve and the Lorenz curve. So Lorenz curves always have some sort of a little belly to them. I was using P. Yeah, I was using P. So there's equal distribution, 0% of 0%, 1%, or 100% of 100%. And then underneath that is the Lorenz curve. And in this case, the equation was 0.3 plus 0.7 p to the fifth power. 0.3p, there we go. Okay. Plug in a 0, you get a 0. Plug in a 1, you get a 1. That's why I'm sure it's a Lorenz curve model. So let's take 2 times the area between those two curves. So this upper curve is the equation y equals p, or y equals x if you prefer x's. So that's that proportion minus the Lorenz curve, 0.3p plus 0.7p to the fifth power dp. So upper curve minus lower curve, integral from 0 to 1. If I do the subtraction, it's p minus 0.3p minus 7p to the fifth power dp. And since I can, I'm going to collect my like terms and make it that much easier, so I only have 2 antiderivatives to do instead of 3. So 0 to 1 of 0.7p minus 7p to the fifth dp. Whoops, that's 0.7. All right. Doing the antiderivatives. Let's see, I'll keep that 2 out front for right now, sort of wall that 2 off. 0.7 raise the power by 1 multiplied by the reciprocal of the new power. Same thing on the next one, minus 0.7. Let's see, that would be p to the sixth times 1/6. Evaluate that from 1 to 0. Again, I'm going to carry the 2 through later. I'm going to plug the 1 in first, and then plug the 0 in, and I'll multiply by 2 later. So if I plug the 1 in, now 1 squared is 1, 1 times a half is a half. This is, so plug in the 1, half of 0.7 will be 0.35 minus 0.7 divided by 6. Let me do that on the calculator here. That's about a 0.117. Okay. I've plugged in 1. I've got those two numbers back. I'm not even going to mess plugging in 0 because both of those are 0. So I have 2 times the quantity. What would that be? About a 0.233, I guess. So it looks like that would be about a 0.466, somewhere around in there. So there is the Gini index for that population and their wealth. Remember, again, this is used for both wealth and for income. Typically, the wealth gap is significantly bigger than the income gap. When you have a lot of income, it's a lot easier to build wealth. If you have little income, it's hard to do anything besides pay your bills. So if you have money to burn, you can invest it and earn like crazy. Yeah, thanks. Yeah, I did get that changed to 0.7. Appreciate it. So there we go. There's our little economics journey on problem number 1. We did 2 things. So we use the Lorenz curve, and the Lorenz curve tells us what the proportion of either income or wealth that a certain percentage of the population has. And then the Gini index lets us get a firm grasp as to how equal or how unequal either the wealth or the income is distributed. So I guess we've done all the problems on part 1, huh? Okay, next question. So one of the questions that I've yet to write, but there will be a question a lot like that, of course, on the exam. So there'll be 2 questions on the exam with the Lorenz curve, one with the Lorenz curve, one with the Gini index. Question 3A it is, Aaron. Okay, according to Forbes, I just found this information earlier in the week. We have a Gini index for the income for the U.S. over the 9-year period. And notice the Gini index every single year, that number grows, right? Yep, 0.467, 0.46, whoop. Yep, 0.469, 4712, 4735. Every year, 1 year after the other, that Gini index is getting closer to 1. So what does that tell us? Well, it depends on which point of view you want to express. I'll write the two. Two things that I notice. So it's a phrase either way. Over that period, it was wealth, it was income, wasn't it? Yeah. The income in the USA was becoming less equally distributed year to year. I guess really that's about the only thing that I could say. I was trying to think of another way of standing this on its head, but it's definitely becoming less equally distributed as the years go by. As the numbers get closer to 1, the income gets less equally distributed each year from the previous year. Oh yeah, I'll have to add another question on the exam. So I'll have one with the Lorenz curve, where I ask you some information. I'll have one where I ask you to calculate the Gini index, and then one question sort of like this that asks you to compare a couple of numbers. So if one has a bigger number, what does that mean? Yep. So there we go. I guess I updated question 2 as well. I was looking at some information in the last couple of days. So question 2 has been updated from previous semesters as well. I think the last time I looked at it, I just had the first 2 pieces of data, and then I got the 2016 data yesterday or the day before. So that's a fairly significant change looking at the numbers, 78, 83, 86, and the 3-year period. That's a really significant change in the percentage of wealth. So to me, the topics in this activity are some amongst the easier ones we've looked at recently, I think. I remember students struggling with them, but this used to come right after exam 4, right between exam 4 and the final, and I think a lot of students at that point were worrying about other tests and had a lot going on, and they weren't really able to have this one sink in all that well. But to me, there's just I worked through that activity. I wrote the answer key, and it didn't seem to take very long. So, any other topics of conversation that you wish me to talk about? We still have, gosh, half hour plus before the quiz opens. like there's always two ways to express answers. So if I look ahead to 3b, let me write up both of the ways that I could express the same idea. On 3b, I'm going to access back to problem 2. So the Gini index in 2016 for wealth was 0.86. The Gini index for income was 0.48. So in 2016, so here's what I would, the two ways that I could express the answers to 3b. So there's one way of saying that the wealth was less evenly distributed, than the income, the bigger number here. Or you could say that would be the two basic ideas that say the same thing. I think it would be a really unusual situation where the wealth was, if the wealth was more evenly distributed than the income, if the income was if the income was less equally, it'd be a situation where suddenly the world is starting to turn on its end. The poor folks are starting to make more money per person than the rich folks are. And that just, I mean, I'm sure there are times in history where that happens, but it has to be a really uprooted time. Maybe the folks in the, if their income is in the stock market, maybe if the stock market crashed, I suppose that might have been a case where some folks had a job and then the speculators lost everything back in the Great Depression. But I can't think of many other cases where that would actually have happened. I'm not an economics person, but who knows? Off to 6A. Yeah, 6A is such a good one to look at. We struggled on that last quiz, and I'm still trying to get everyone to understand exactly what these curves are. Whoops. Are you talking about 5A, Aaron? Yeah, 5A, sure. I'm trying to get everyone to understand what the antiderivatives do, what the area under the curve is, and what the rest of that is. So there we have the infection rate, and I pretty well took the graph off of the information that came from Washington State, built an equation that modeled it really closely. I know enough about some distributions to come up with a model that fit really well. And man, you could go to the Washington, I'm not sure, Department of Health, I think it was the Washington Department of Health that showed this, pretty much this curve perfectly. So what would that represent? Well, here we have the infection rate. And this is measured in cases per day. And by the way, I think this is about where we were the last time I looked. So in Washington, the number of new cases each day is certainly on the downhill slope. It's still a fairly high number, but it's definitely going downhill quickly. So let's talk about what the area under the curve measures. And that, the first thing you should know is if you have a definite integral, that this will calculate the area under the curve. This is in the days. So when an area under the curve is going to have the units of this times this. Cases per day multiplied by days. Every time, no matter what, if you have a units over here and units over here, and you're looking for the area under the curve of those units, the way you measure it is you multiply these units times these units. It doesn't matter if these are what kilowatts and those are hours, or these are cars per month and those are months. The units always work out the same way. So this is going to give us the number of cases, okay? And what's going to give us the number of cases from the 50th through the, let's see, 0. Well, let me make sure I get this going right. 50 days through 55 days, yeah. 50 days through 55 days past, was it February 1st? Yep. And there's 50, 1, 2, 3, 4, 5, 1, 2, 3, 4. That's that 5-day period, right? So that's the number of new confirmed cases. That 5-day period that starts 50 days after February 1st, 2000, something like that. It's the number of cases, however, and that's the major important thing. Okay, so if you look at that between 50 and 55, we're sort of on that big upturn here. I think at 50 to 55, it looks like we might have started, the rate started slowing down. There's an inflection point right there. Before the inflection point, the number of cases was growing more quickly than afterward. So I think that's sort of the inflection point, the point where it's a little bit of a turning point there. But that's right about where the new cases per day were at their max. It was gaining steam about as quickly as any other time in that period. So between 50 and 55, looks like it was spreading quickly. Okay, so if I look at part B, I'm looking at this little area of the curve right there, and we come up with the average value. So for part B, I have the 1/5 in front of it. This is 5 units wide. That is going to give me the average infection rate. So here again, make sure you understand how the words work and how the units work. This is the infection rate for that 5-day period. If we take the number sort of right in the middle of that, that right there will be the average. The average infection rate. It'll be measured in the same way that that the curve will be measured. We're taking this curve that goes up and we're making it a flat curve. This flat curve, this flat rectangle, has the same area under it that that oddly shaped curve had. So we're taking the hills and the valleys out of that, and we're coming up with a nice average. So find the average on part C. So we're going to read across here, sort of in the middle of that. If you read across, see, at 50, it looked like we were at a little under 200. By the time we're at 55, we were about 250. I guess somewhere around maybe 210 or so. 210 cases per day. That was about the average number of new cases in between day 50 and day 55. So that's all of problem 5. And I put problem 5 back on there. It wasn't on the last, obviously it wasn't on the last one because we didn't have any of this going on, but I put it back there just because too many people, I thought, struggled with that last quiz. So what is the derivative measure? Area under the curve. How do those units come out? And that was the thing that I think was most distressing, is people were not putting the correct units in. The area under the curve, or whatever those units multiply together to give, in this case it's cases. And the average is always the same units as the original curve is. We're replacing a small section of that curve that goes up and down with the section that lies flat. So we're flattening out that curve. Talk about curve flattening. For B and C. Yep, hey, I did that. I must have been thinking ahead there, Isabel. Can we please do 4C? Sure, we'll go back and pick up 4C now. And we'll talk more about this. There's plenty of practice. I made sure there was plenty of practice problems like this on the review that you're going to have a chance to look at, or maybe you've already had a chance to look at it. Exam 4 review has been up and posted. I think I finished that on Sunday, if I'm not mistaken. I did amend it a little bit to get a few more problems that deal with areas under the curve and the real world problems. So off we go to problem 4C. Find the area between the equal distribution curve and the Lorenz curve. Okay, so let's see, we need goes from 0 to 1, 0%, 0% to 100%, 100%. We want the area between those two. Again, that has the equation y equals p or y equals x, depending on what you're using for your variable. The other one is also a function of p, again, a little bit of the belly. And that one has an equation of 0.0525 e to the positive 3p minus 0.0525. Okay, off we go. So it's the upper curve minus the lower curve, p minus 0.0525 e to the 3p minus 0.0525. Let me check those numbers. They look good. Let's do the subtraction. 1 to 0, p minus 0.0525 e to the 3p plus 0.0525. Oh, don't forget the dp. Off we go then to the antiderivative. Antiderivative of p. Oops. 1/2 p squared. How about this next one? How about our second term of our antiderivative? I'll do the first one and the last one because they're easy. Power rules, huh? So let's keep the p, raise the power by 1, reciprocal of the new power. This one's power 0, make the power 1. What's the antiderivative of negative 0.0525 e to the 3p? Someone help me out in the chat box, please. Looking out my window, it's snowing and sun shining at the same time. I'm not sure if there is such a phenomena, but could there be a snow bow? It's weird. So what do we get for that middle term there? 0.0175. Okay, minus 0.0175 e to the 3p. Yeah, that's exactly right. Remember, you have to multiply by the reciprocal of the derivative, so you multiply that through by a third, and a third of 0.0525 is that. Good, good. Remember the minus sign as well. Plug in p equal 1. Plug in p equals 0. Plug in p equals 0 is going to give us some information on this one. So plug in p equal 1. Someone tell me what you get there. I can plug in p equals 0. I can do this one mentally. Plug in a 0 gives the 0 there, gives the 0 there, gives a negative 0.0175 on that part. So someone plug in a 1 and tell me what we get. That's more complicated than my little piddly calculator can do. I can check my work to make sure I got it right. So plug in p equal 1. What do we get in the top part of that before we do the subtraction? $201, okay. And we're going to subtract off from that minus a negative. So we'll add on that 0.0175. Interested if anyone got that same number. I had something different on my answer key. Doesn't mean that that I'm right, however, and that answer's wrong. So I'm looking back, we did the problem right, I'm pretty sure. Yep. Subtracted, yep, switch the negative sign, yep, got the right antiderivative, yes. So if someone could confirm Aaron's 0.201 here, I'd appreciate that. And there's a chance that I messed this one up a little bit. Okay, thanks, Isabel. So If we subtract that off, we add on 0.01. Oh, yeah, that's right. That's what I had before. Okay, yep, about a 0.219. I couldn't have my decimals there for a second. Sure. So that's exactly what I got. Everything looks solid. Good job. So we have that. Now that's not, of course, that's just the area between the curves. What would we do to that then to come up with the Gini index for the income distribution here? Yep, and I think once that's done, have we done every problem on here? Talked about 4A, talked all the way through 5. Guess the only thing we haven't done is 2, and that's just a comparison. So yeah, the 0.201 is correct. Add on to that a 0.0175, maybe that rounded to 0.0118, I'm not sure. Anyway, when I rounded to 3 digits, I got 0.219. That's what the answer key had, and that seems to make sense. Yep, multiply by 2, exactly right, Aaron. So that covers everything except for question 2. And question 2, just as a comparison, wealth in the U.S. was, yeah. So if you look at the Gini index for wealth, it sort of follows the Gini index for income, less equally distributed in 2013 than it was in 1989, even less equally distributed in 2016 than 2013. Or if you want to go the other way, the wealth was more equally distributed in 89 than 2013, which was more equally distributed than in 2016. So as time went by, now we're not sure, according to that, we just had those 3 years. We're not sure that it was a continuous march from year to year. We don't have that data like we did in problem 3. In problem 3, we could change it year after year after year after year. In problem 2, all we have are those 3 snapshots. So we can't really say anything about the intervening years. We can say it's less equally distributed in 2016 than 2013, and that in turn was less equally distributed than it was in 1989. Right. So again, we don't have enough data to say it's been continuously less equally distributed in that however many year period that would be, 16-year period, 26-year period. But we do have those 3 snapshots, and that takes us through everything, I think, huh? Anyone have any more questions? So it's a nice, easy one, I think, to end on going into the next test. I think I used to schedule the test before this because I didn't want a whole bunch of people taking the test the week before finals. And that, I think there's a little less stress on us this time. We get this out of the way on a Thursday. That gives us the whole weekend. We come back for another class. Gives us, again, most of the week until that next Friday comes around. So I don't think that these two got placed too closely together. This one and the final. So any more questions? So don't forget that today's quiz, I know I caught a couple people off guard last time, and I put it in the description this time, but there are definitely 2 questions on today's quiz. I always thought that the submit button was way down the bottom of the screen on the right. So I'm hoping I didn't catch too many people off guard last time, but I know I did a couple folks. All right, I'm going to double check the deployment of the quiz, and then I'm probably going to check out for the day. If you have any more questions that come up later, send me an email. I'm not sure when I'll get to them. I have class till 7:10 tonight, but maybe there's a little break from 5 until 5:30. But I'll certainly get to them first thing in the morning if I don't get to them tonight. So good luck on today's quiz, and I'll look forward to spending some time with many of you tomorrow during our first review for exam number 4. See ya.